Welcome to my video tutorial on pH and calculating the hydrogen ion from pH for strong acids. In 1909, Danish biochemist Søren Sørensen brewed beer for Carlsberg. He measured low concentrations of acid in beer, so developed a way of avoiding low concentrations. So by recognising that small numbers can be expressed in their standard form, he realised that he could use the logarithmic scale, log to the base 10, so this value would actually come out as -5. The pH scale can be defined as minus the logarithm to base 10 of the hydrogen ion concentration in moles per decimetre cubed, where P is the mathematical shorthand for negative log to the base 10. So what we can say is that pH 2 is actually 10 times the hydrogen ion concentration than pH 3. This stands for the concentration of hydrogen ions in a solution measured in moles per decimetre cubed. In strong monoprotic acids, we know that virtually all of the hydrogen ions fully dissociate, and so we can say that the concentration of the hydrogen ions in a monoprotic acid will be the same as the concentration of the acid. So let's take hydrochloric acid, which we know is a strong monoprotic acid. What we can say is that 1 mole of hydrochloric acid will fully dissociate to produce 1 mole of hydrogen ions. So for acids such as hydrochloric acid and nitric acid, the original concentration will be the same as the hydrogen ion concentration. So for a 0.1 molar concentration of HCl, the pH will be negative log to the base 10, and then that concentration, 0.1. And if you pop that into your calculator, it comes out as 1. As an exam tip though, always give pHs to 2 decimal places. Let's say we had a 0.01 molar concentration of nitric acid. The pH would be negative log to the base 10, 0.01, and if you pop that into your calculator, it comes out as pH 2. Note here that a weaker acid has a higher pH number. And a quick reminder how to put that into your calculator. You want to put negative and then press the log button and then enter the the concentration of that strong acid, then close brackets and then press equals. So what if you have the pH of a solution and you want to know its hydrogen ion concentration? Well, you just need to inverse the pH formula. So the hydrogen ion concentration is equal to 1 times 10 to the minus pH. So what would be the concentration of the hydrogen ion for HCl if it had a pH of 1.35? Well, the concentration of that hydrogen ion is equal to 1 times 10 to the minus 1.35. And if you pop that into your calculator, it comes out as 0.045 moles per decimetre cubed. So on my calculator, I put 1.0 and then I press the shift button, then the inverse log, minus, and then 1.35. Strong diprotic acids, such as sulfuric acid, release 2 protons when it dissociates. So this means that the hydrogen ion is twice the concentration of the acid. So what would be the pH of a 0.1 mole per decimetre cubed of sulfuric acid be in solution? Well, first of all, we have to multiply that concentration of the sulfuric acid by 2, which comes out as 0.2 moles per decimetre cubed. Then, as we recall, that the pH is equal to the negative log to the base 10 of that hydrogen ion concentration. And once we put the numbers into that, we can see that the pH would be the negative log to 0.2, and if you pop that into your calculators, it comes out as 0.7. Now, this rule really only applies for strong acids or strong diprotic acids, and you can't apply the same rule to weak acids or weak diprotic acids because they don't fully ionise, and we'll go through that in my next tutorial.